Hello friends, myself Niyati Chauhan, Assistant Professor at AJ Institute of Engineering and Technology, Department of Instrumentation and Control. Our subject is Environmental Instrumentation. We have started Unit 4, and in Unit 4, I have discussed about how to measure and monitor of carbon monoxide in last lecture. And in today's session, I discuss about measurement and monitor of sulfur dioxide. So let's start today's session. Sometimes in GT, question can be asked, explain CO2 monitoring analyzer or explain SOX, right? So here we can use fluorescence method, right, for measurement of SO2. So SO2 molecules absorb ultraviolet light and become excited at one wavelength. Okay, you can see first equation, right? So SO2 plus HVA. So here HVA, that means at one wavelength SO2 absorb and SO2 reach at excited state. After some times release energy and go back at ground level, right? So in second chemical reaction you can see SO2 star, then SO2 plus HVE, right? So HVE, that means emitting energy. Okay, so in sentence that decay to a lower energy state emitting UV light at different wavelength. Okay, first chemical reaction SO2 plus HVA, we get SO2 star. Okay, so SO2 reached at excited state. After releasing energy, go back at ground level. Okay, so in statement that decay to a lower energy state emitting UV light at different wavelength. Okay, so in both chemical reaction we can say that in first chemical reaction SO2 absorb energy, right, and in second chemical reaction SO2 release energy, okay, in any wavelength. Next, there is measured between of how much UV light is created based on how much SO2 present in the sample, right? Here we are using fluorescence method. So in bracket I have written SO2 fluorescence. Sample first flow through hydrocarbon kicker, right? Why we are using hydrocarbon kicker? Hydrocarbon kickers remove hydrocarbon from the sample by forcing the hydrocarbon molecules to permeate through a special tube well, right? So here we are using hydrocarbon kicker for removing hydrocarbons from the sample. The sample flows into a fluorescence chamber, right? Fluorescence chamber known as optical chamber. When pulsating UV light causes the SO2 molecules to fluorescence. Okay, so our sample pass through the optical chamber, right? The pulsating UV light is directed into a mirror assembly containing 4 selective mirror, that is a band pass filter, okay, that reflect only the wavelength which excite SO2 molecules, right? Here we are using 4 mirrors, right? And 4 mirrors react as band pass filter, right? So one particular wavelength SO2 excite, right? So for this purpose we are using 4 mirrors. You can see in diagram, this is our light source, right? are for mirrors. Okay, we are using as a band pass filter, and light passing through mirror, right? You can see this is the optical chamber. Optical chamber known as fluorescence chamber, right? And this is a hydrocarbon kicker. We are using hydrocarbon kicker for removing hydrocarbons. And from hydrocarbon kicker to optical chamber, our sample first go through the hydrocarbon kicker. In hydrocarbon kicker, removing hydrocarbon. Then after, sample goes to the optical chamber. And from optical chamber, the sample goes through the photomultiplier tube. And then after, sample goes to the analyzer electronics. Okay. From analyzer electronics to return in photomultiplier tube, and from multiplier tube to signal goes to in return optical chamber, right? And from optical chamber, sample goes to the from optical chamber, sample goes to the flow sensor, and from flow sensor to sample goes to the pump, and pump through sample out, right? Here we are using light source, right? And from light source to signal goes to in first mirror to second, then third, and then fourth, right? So here 4 mirrors we are using as band pass filter, right? Why we are using mirrors? Because SO2 excites at one particular wavelength, right? So that we are using here 4 mirrors. Okay. So first sample goes to the hydrocarbon kicker, then hydrocarbon kicker to sample goes to in optical chamber, right? In optical chamber, okay, one particular wavelength SO2 excited. Then after sample goes to in photomultiplier tube, and from photomultiplier tube to sample goes to in electronics analyzer. Then after return from electronics analyzer to photomultiplier tube, and from photomultiplier tube to the optical chamber, right? And after optical chamber, we are using flow sensor. Okay, and then after our sample goes to in pump and pump through sample out, right? So this is the process of measurement of sulfur dioxide. Okay. Next, the photomultiplier tube detects the UV light emissions from the SO2 molecules and sends out a voltage signal which is calibrated to the amount of SO2 present. Okay, so here we are using photomultiplier tube, right? And PMT detect UV light emissions, okay, from SO2 molecules and send out a voltage signal. Okay, so send out PMT, send out voltage signal to electronics analyzer. Okay, and then after we can calibrate how much SO2 present. Next, a photodetector located at the back of fluorescence chamber and continuously monitor, right? So here we are using photodetector, and which is located at back side of optical chamber, right? For continuously monitoring. As the sample leaves optical chamber, it passes through the flow sensor, okay, and exits from the pump. Next is analytical methods for air pollution. Okay. So pollution control systems are designed to significantly reduce concentration of pollution exhausted from an industrial plant. Right? So here we are developing pollution control system, right, for reducing air pollution. Okay, for reducing the pollution, right, which is created from industrial plant. Pollutant remove 90 to 99% of volatile organic compounds in exhaust steam. There are 4 methods for air pollutant measurement. Number 1, thermal oxidizer. Number 2, catalytic oxidizer. Then that's and last method is scrubber system. Okay, so let's start from first method, thermal oxidizer. In thermal oxidizer, they use thermal energy to oxidize. Oxidize, that means burn. Oxidize the pollutant in an air steam as it passes through a heated chamber. Okay? Thermal oxidation requires high temperature to break apart the pollutant compound. So here we are using thermal energy for thermal oxidation, right? And we have to maintain temperature, right? Because at high temperature, pollutant can be brought down. Okay. Then oxidizer has a burner system and combustion controls that regulate the chamber temperature at a temperature of 1400 to 1600 Fahrenheit, which is sufficient to destroy volatile organic compounds by means of oxidation. Right? So here in burner system we are doing oxidation. Right? So we have to maintain temperature, and temperature will be 1400 to 1600 Fahrenheit. Right? And this temperature required to destroy volatile organic compounds. Thermal oxidizer use a ceramic fiber insulation on the inside, which is lighter and more recyclable. Oxidation process. The oxidation process we will see in video, right? And this video regarding to process of thermal oxidizer. Next, catalytic oxidizer. Catalytic oxidizers are another hybrid form of two thermal oxidizer. A catalytic converter, much like those used to reduce emissions from automobile exhaust, it is a destroyed volatile organic compound. Okay, so here we can see catalytic oxidizers are one type of hybrid form of thermal oxidizer, right? And catalytic converter. Okay, so here we are using catalytic converter for converting pollutant to the carbon dioxide. Okay. Next, catalytic treatment of volatile organic compounds and other air pollutants work by reacting the harmful air pollutants over a specially designed previous metal catalysis where VOCs are converted to carbon dioxide, water vapor, H2O, and usable heat. Right? So here we are using catalytic converter, and which is convert pollutant to carbon dioxide, water, and in form of energy. As the air passes through the heat exchanger, it is heated and will then exit into a section and is called reactor. Okay. Here air passes through heat exchanger. It is heated and will exit into section, and that section is called reactor. Next, as it enters the reactor, the process steam will be further heated by a burner control by a thermocouple measuring the temperature of the air and a temperature. Controller regulating the burner firing to bring the process stream up to the catalyzing temperature of 300 to 700. So here air pass through the reactor, right? So in this process we are using thermocouple, right, for measurement of temperature, and we are measuring temperature of air, and we are controlling and regulating up to 300 to 700 degrees Fahrenheit. The catalyzing temperature depends on the organism. The requirement for the destruction of the organism and type and volume of catalyst, right? So here catalyzing temperature depend on the organism, which type of organic we have used. The requirement of destruction of the organism and which type of organic we have used, its volume, right? So that is depend. Thank you for watching video.